Right, hello and welcome back to another video. So today we're going to be looking at runtime virtual textures, what they are, how they work, how we can set them up, and then how we can use them in our scenes to do some object blending with a landscape, or also how we can make things that conform to a landscape. So just going to jump over to the documentation. So virtual texturing, it's a relatively new feature in Unreal. Only been around since 4.26, and it's definitely a push that they're going to be doing more with in the future. Documentation here about how to set it up, worth reading through sort of the background, and there's a little sort of setup tutorial here, but we're going to be covering a lot of this stuff as well. So what is it and how does it work? Well, basically when you're painting something like a landscape, it would be really powerful and really useful if you could access the sort of final painted texture of the landscape, and that's what runtime virtual texturing allows us to do. We can take the painted scene and then write that to texture and then read that back again, and that allows us to do some very powerful things. So not sure if you can see in here, but there's actually a couple of small spheres, and if I just zoom in on that, this is reading the same landscape material textures as what's underneath. So if I bring this up and kind of move it around, you can see it's a top-down projection. We are getting a little bit of smearing at the sides. Obviously with any kind of top-down projection that's always going to be the case, but if we scale this down we can get a really nice result. Just ignore the shadow that's baked in, but if we look at this, the transition or the sort of the seam between where this sphere is and where the landscape is almost impossible to see when you get it from the right angle. Obviously a little bit of shadows might cause issues, but if we disable the shadows, there we are. Now you might have seen my other video on object blending, and this is kind of the next step. So the more powerful version, using the more kind of up-to-date technology, and you can get a really smooth result with that. So that's one very powerful thing we can do with runtime virtual textures. And the other one is, if I go over to this blue plane, we can also take the height information. So here we've got just a really simple plane with some geometry. There's enough divisions to it so it's going to deform and conform nicely to the floor. And we're actually taking the texture, or taking the landscape height, writing that to a texture, and then reading that back. And as we move this around, you can see it's conforming really nicely. Now, if you've ever done any kind of smoke or fire or snow simulation type particles that you want in your world, you really want them to conform nicely to the surface, and this technique is going to let you do that. So again, another really powerful way of doing that. If I just zoom in a little bit here on these icons, so you can actually see the two textures that we're creating virtually at runtime. So that's this one here, the material, the texture, base color, normal, roughness, everything all saved into one texture, and then the height is a separate one. So these have to be set up separately, but we'll do that in a second. So that's what we can do, or at least a couple of things we can do with runtime virtual textures. So let's jump over to a brand new level and set this one up ourselves. Let's check that out. Fine. So here I have just a basic landscape, and it has a landscape material assigned to it. So this isn't set up to use runtime virtual textures at all, and we're going to go through step by step to do that sort of conversion. So this is a landscape material. If you are unfamiliar with landscapes, check out my other videos. I've got a whole series talking about different landscape videos, but just to quickly go over the material here, we've got two layers. One is plaster. This is just textures that I had in this project already, but they work for sort of demonstration purposes. So yeah, one of them is plaster, and I'm using base color, normal, and ambient occlusion. And then another one is mud, and you can see here we've got the mud layer. We're blending them together using the landscape blend tool, and I'm using my my UVs are projected, so it's a top-down projection for that. And then I've got my material attributes as a single pin, so I'm using the material attributes setting down here, and that allows a little bit easier to work with to sort of blend these things together. Okay, so the first few steps we're going to do to set this up, we're going to add a switch node. Now, as I said, this is quite a new thing. it needs to be enabled in your project. So in fact, before we even go into the material, let's show you where that is. So if I go into my project settings, all settings, virtual, down here, enable virtual texture support. So I've enabled this. It will require an engine restart, so I'm not going to do that now, but we want to enable this, and that allows us to use this feature. But we also want to make sure that the material that we're making supports versions of the engine that don't have this feature enabled, and that's what this switch in the material is going to do. So if we are using the virtual texture switch, yes, we'll set up that in a second, but if we're not, we just want to use the material as we already had it. So we're going to disable this depending on what we're doing. So the next step we're going to do is we're going to take this information in the material, and we're actually going to write it to an output. So down here, if I type in virtual, you can see there's a few different material nodes that refer to the virtual texturing sort of pipeline, and this one is what we're going to use, Runtime Virtual Texture Output. And what this is going to do, it's similar to a normal material output, but rather than rendering to the screen, it's going to render it to a texture. So I'm going to take the information here, and I'm just going to break material attributes. Again, if this is sort of an unusual pipeline for you, have a go back through the landscape material videos, and we talk about making and breaking and how it's easier to work with these as sort of single pins. And all we're going to do is we're going to plug the data that we want into this output node, and so the base color is going to get written, the roughness, the normal, but there's a little bit of a trick with the normal, and we'll come back to that one in a second. The world height, well actually let's do the normal now, fine. So we could plug this in like this. The normal map here would then be written to our virtual texture, but we need to talk about coordinate spaces, because the normal here, coming from the material, this kind of normal map, this is what's called a tangent space normal. So it's encoding the surface detail, but relative to the plane, or relative to the face that's being textured. So it doesn't matter how we rotate that texture around, or that face around, it's always going to calculate the normals correctly, because the normals are defined relative to that face. When we're doing our lighting calculations, all of those normals are converted into world space normals, and I'm going to kind of show you that in here. So if I bring in a quick plane, I'm just going to scale this up for ease of use. I have here a material, has my normal map plugged in, both as a normal and as an RGB, so we can see it's getting a kind of lighting response from the normals, and we're also able to preview the color. And if I rotate this, the color of the normals is always the same, because that color is sort of showing us the preview of the tangent space normal map. But if I convert this to show the world normal converts that tangent space normal into the world normal. So now this is sort of relative to the world coordinates. And you can see as we can move this around, we're getting different colors. That's because whether it's facing the green axis, it's going to be much more green. This is what we can then use in our world space lighting calculations. Hopefully that makes sense. How this becomes useful now is when we're using the runtime virtual texturing, it stores all that normal information in world space normal. So if we're writing to that, we need to convert from tangent space to world space. Most of the time when you're dealing with Unreal, you're just happily using tangent space normals, that's fine. When we get into slightly more complicated shaders, sometimes we need to sort of convert between world space and tangent space. So let's put that back to lit. It's back to our material here, landscape. This normal here is in tangent space. This normal input is looking for world space. And so all we need to do is drop in a transform node. And what this will do is allow us to sort of convert the numbers from one space to another. And the default is actually what we want here. We're converting from tangent space to world space, and then we're writing that out to the world space normal, or the world space normal to our virtual texture. Height, well, we don't have any height information here, but we do have height information from our world, from our actual kind of 3D geometry, from our landscape mesh. So if I take my world position node, this will output the per pixel height information or position information, and what we're going to do is we're just going to mask out only the blue channel, because that's going to give us our height. So this is our per pixel world space position, this is our per pixel world space height, and we can plug that directly into world height. We're not going to be using the opacity and mask inputs, but just for security we're going to put these both to be 1. And now if I click apply, it's going to give me an error. If I just bypass that one for a second, what this is going to do, as well as rendering the material up here, it's going to allow us to read the information from the material as a virtual texture. Just give it a second to compile. So if we jump back over to the world, we aren't going to see anything different. We're still seeing the rendered material, no problem. But now we've added that ability, like I say, to write to a virtual texture. So how do we set this up? Well, there's a few different steps. First, we need to have a virtual runtime texture volume, which is just an asset that we can create. And if we have a look, we need to tell it which landscape to read from, or sorry, which actor to align with. So in here we have a bounds align actor, and I'm just going to use the eyedropper, and I'm going to pick this landscape mesh. Now we can't set the bounds yet because we also need to tell it which texture to write to. So it's saying, where am I reading my information from? That's our landscape. Where are we writing that information to? Well, that's going to be a virtual texture. Now I do have a couple in here set up for the example level, but I'm just going to create a new one. So anytime you have a drop down menu like this at the top, there's always a create new option. And if I run over to RVT, I'm just going to call this class RVT, and this one's going to take the whole material information. So I'm just going to call it matte info. There we are. That works. This is going to be our base color, our roughness, our normal, and now you see this set bounds button is now available. So if you click this, it's going to scale our volume to be exactly the same sort of shape and size as the bounds of our landscape. And then there's one more thing we need to do. We go back to our landscape. This material has that runtime virtual texture kind of capacity in it, the logic in it, but we also need to tell the landscape to actually do it. So go down to this virtual texture step, draw in virtual texture as well, yes, and I'm going to load in the one I just created, this matte info, and you can see here in the preview it's now shown us that information. So it's taking the plaster and the mud here that's painted on the floor, and if I actually go into the landscape mode and just paint a bit more plaster and then come out here, you can see that updates as we mouse over it. So it's taking that and it's giving us a full dynamic runtime result, which allows us to then kind of like paint and record that surface. That's good, that's working really well. One more step, I'm going to go back to our landscape. We've written it out to a runtime virtual texture, but we actually want to read it back in here as well. Runtime virtual texture sample. So another node to do with virtual texturing. In this case, we can now read back from that texture. So class runtime virtual texture. And we can tell it here we're reading the base color, normal, roughness, and specular. And what we're going to do is a make material attributes and just plug these things in. So base color to base color, roughness to roughness, and then normal to normal. And now this is what we're going to use when we're using runtime virtual texturing, and we're not going to use it if we're not having that feature enabled. Now there is one more step. Down here we converted from tangent space normal into a world space normal, and then up here we're reading that world space normal back in again. Now we could put a transform in here and convert it back. That would work perfectly fine, no problem with that. Some nice symmetry, converting it one way and then converting it back. But if we go over to our material properties and type in tangent, we can actually disable it on the material itself. Now tangent space normals are actually a little bit more expensive to calculate. So if we have a world space normal here and we want a world space normal at the end, we could just disable this, and that's going to be a slightly cheaper way of doing that. rather than converting from world to tangent, tangent to world, and then world to tangent again, back to tangent to world. It's like unnecessary calculations that we don't need to do. So by having this set as disabled in tangent space normal, this is now looking at for a world space normal in the output, and that's what we have here is a world space normal. And so if we apply this, that will give us, why not check these out? This will give us no visual difference in terms of what we're seeing here. It's still going to be taking that painted material, writing it to a texture, reading that texture back, but now we can make other materials that read that texture as well. So if I just create a new material from scratch, manifolds class RVT blend. If we open this up, so same thing. We're going to start with that sample, virtual texture sample. Tell it to use that texture. In this case, it was the class one, and then plug these values straight through. And so this is going to take the color, roughness, and normal of the painted landscape and just pass it through to this object. And again, we need the normal to be in not tangent space, in world space. So if I save this, let it compile quickly. If I drop that sphere in, and I'll just scale this up and down a little bit, and apply that material, we're getting that blending. So there's lots more we could do with our blending. We could use distance fields to pick things up. We could have a sort of custom sculpted rock that had a sort of skirt mesh around it, and that mesh blended in. So there's lots of ways we can kind of combine this with other techniques, and if you want to know a bit more about them, check out the other video on object blending. But as a way of sampling the material underneath, getting all that information, and getting a kind of like near seamless blend between these things. Again, there are going to be some issues, so where you get stretching or if there's any shadows, but depending on what you're doing and how you're doing it, this is a really, really powerful way to do that. Cool. One last thing, and that's the Heightmap. Let's save this out in a second. So same approach. So our material here, my landscape, it's already set with a height output. You can see here we took our world position, masked out the blue channel. Well, with our height information, if I just create a new material, class height, there we go, we can do a another texture. So if I open up the settings for the runtime texture that we've created, now there's some details in here for how big you want it. Obviously, the larger it is, the more memory it's going to take up, slower it's going to be, but the higher the resolution. But down here we've got virtual texture content. So this was the default to use base color, normal, roughness, and specular. That's great. But down here we've also got another one for world height. So we can't use one texture to store both, but there's nothing stopping us telling our material or telling our landscape to write to two different virtual textures. So we need another volume. So I select this volume, I'm just going to Control W to duplicate it, still set to the same landscape, create a new runtime virtual texture. I'm going to put that in here in RVT, and I'm going to call this class RVT height, and that is going to now read our height information. So if we double click it, change it from full base color, normal, roughness, and spec to world height, and then save. And then if we select our landscape, we need to tell it to write to that texture. So down here in virtual texturing, class RVT height. When you've done this correctly, it will update the preview, and you can kind of see here you've got the different things. So the white values are the tops, are the peaks, and the black values are going to be the sort of valleys. And that's now a height information that we can read back in our other shaders. So if I open that other shader here, I'm going to do a sample virtual texture. I'm going to sample that height one, so class RVT height, and it automatically picks up that that's what's in the thing, in the texture. And I'm going to take that, and I'm just actually going to take a 0, 0, and append that value to it, and append that world height. And so this is now giving me a vector where it's the distance from 0 up to that pixel. And if I plug that into world position offset, I'm just going to give it a color here so we can see a little better. Let's do red this time. This is going to take our mesh and then move it up to the world height based on the height of the object. So hopefully if I just save this and bring in a plane and apply it, you'll be able to see what I mean. Now if I bring in just a plane, this is going to work. Here it is. And I apply the Runtime Virtual Texture class height setting. So you can see it's done something. Right, let's scale this up a little, make it a bit easier to see. Well, it's taken the height value here and it's added the height map. So if I take this, pushed it down to 0, that's now going to be conforming exactly with our landscape. Maybe give it a few units off. If I move this around. Now, there's a problem here. The default plane doesn't have any geometry. It's just a simple 4 vert plane. Sometimes that's fine, but anytime we're using world position, doing any deformation, we need verts to be able to deform it. So rather than using the default plane, I'm actually going to use this one here, the planar reflection plane. And this is a little bit bigger, but it also has geometry in it. So if I look at the wireframe here, you can see there's quite a lot of density. So now each one of those vertices is going to align to the surface, and it should, as I move this around, conform. Oh, obviously it's not going to conform around the sphere. The sphere is something else, not part of the landscape. So it's not quite perfect. One problem we've got here, the landscape's lodding as I move towards it and further away from it. It's a very small landscape, so the lodding is very aggressive. But if I just go in here and turn off or set max lodd level to 0, that's now not going to deform, and we're going to get a much better sort of alignment between these two things. And you can see here now, reading that height map. And what's nice about this is it's all dynamic. So if I go in here and I do a landscape and then sculpt, I'm just going to smooth this out a little bit, maybe add a little bit here, change all that surface, and you can see that texturing, well, it's not completely live, but it's updating with our object. Now you might get this issue, this flickering. This is a problem to do with the bounds. If you want to know more, I made a video about bounds quite a while back, but basically what's happening is the engine thinks it's off screen even though it's not, because we've artificially moved it due to the shader. So if I enable bounds, you can see, if I can find it, yeah, the bounds of the object are down here. So this is where it thinks it is, or the engine thinks it is, but actually it's rendering up here. And there's a very simple fix for this. If we go into our bound scale, and just scale that up, and now the engine thinks it's bigger than it is. That might be too much, little. There we go, and that's fixed our flickering. Oh, still a little bit more. There we go. Cool. So yeah, really powerful feature. Like I say, anything you want to conform to the surface of your landscape, definitely useful in sort of snow, sand, things like that, where you're blowing along a surface. You want a particle system that's spawning these and blowing these along. Very useful sort of set of settings or set of tools to do this. Or blending, object blending, very common problem with game art. You make a nice landscape, you make some nice rocks, now you need to blend the two together seamlessly. Well, now we have Runtime Virtual Texturing, we have the ability to do that. So do check that out. Awesome. So hope that has been helpful and informative. As always, big thanks to my Patreon supporters for supporting the channel. I've had a lot of new supporters recently, so yeah, thanks very much for that. Going to try and keep updating. It's been a little bit spotty over the last few months, I appreciate, but now hopefully I'm going to kind of get back to weekly or sort of bi-weekly updates. So So yeah, if you do have any questions or comments, or you want to support the channel, please do, and I will see you all next time.